All right, today we're diving into something called the Model Context Protocol, or MCP. Now, I know it sounds super technical, but trust me, this isn't just about code. It's about giving AI hands, a way to actually interact with our world, and it's fundamentally changing what's even possible.
You know, for the longest time, our smartest AIs have been brilliant, but, well, trapped. They can spit out text, write some code, answer pretty much any question you throw at them, but they can't act. So the big question has always been lingering. What happens when we finally let them out of the box? What happens when they can interact with the world around them?
This comparison right here really gets to the heart of it. An isolated AI, that's a brain in a jar. It's like a musician who knows all the theory, every note, but can't actually touch a piano. An agentic AI, though, now that's an assistant with hands. It can actually play the instruments. And that shift from just knowing something to actually doing it, that's everything.
So how do you give an AI hands? Well, for a while now, the answer has been messy. Really messy. Developers have been stuck building these custom, one-off connections for every single little task, using things like function calling. Just imagine having to invent a completely new type of plug and a new wall outlet for every single appliance in your house. That's pretty much what building AI agents has been like. Every single time you wanted to connect your AI to a new database or a new API, you had to start all over, right from scratch. It was slow, complicated, and just impossible to scale. But what if there was a universal standard? You know, a single, elegant solution to all this integration chaos? Well, that is exactly what the Model Context Protocol, or MCP, is designed to be. At its core, MCP is really just an open-source rulebook. Think of it as a standardized language that lets any AI application talk to any external system. Doesn't matter if it's a database, a piece of software, or even a physical robot. It creates that all-important common ground for communication. In this analogy, it's just perfect. Just like USB-C finally gave us one universal port for all our gadgets, our phones, our laptops, everything, MCP creates a universal connection for AI. You can build your tool with an MCP server just once, and then any AI that's compatible, whether it's Claude or some custom model you're running locally, can instantly plug right in. No more custom wiring, it just works. So how does it actually work under the hood? It's pretty straightforward, really. The architecture has three main parts. First, you've got the host. That's the AI application itself. Inside that host is a client, which is like a universal adapter. And that client talks to a server, which is the gateway to whatever tool or data you want to use. Host, client, server. That's the magic trio.
So, and this is the crucial point. By creating a standard, MCP isn't just solving a technical problem. No, it's unlocking an entire ecosystem of brand new possibilities for what AI can actually do.
And the variety we're seeing already is just stunning. Developers are building MCP servers for literally everything you can think of. Want your AI to scrape a website? There's a server for that. Need it to mess with your cloud setup on Cloudflare or manage a Supabase database? Yep, servers for that too. It can even use Git for version control or poke around your local file system. And this scales up to some truly mind-blowing stuff. With something called Xcode Build MCP, an AI can literally build and test an iOS app for you. With NWO Robotics, an AI agent can control physical robots out there in the real world. It can dive into Kaggle to do data science or connect directly to Google's official services. That assistant with hands idea? It's happening right now.
This ecosystem of tools isn't just about unlocking new features either. It has a massive impact on the bottom line. By standardizing all these connections, companies are seeing development cost for AI integration drop by as much as 70%. That is a true game changer for getting these solutions deployed at scale.
And the results really speak for themselves. We're talking real-world productivity boosts between 35 and 40%. Can you imagine a customer service team handling 3 times the number of queries and solving problems 40% faster? This isn't just a theory, it's a measurable revolution in how businesses operate. But, and you knew there was a but, with all this incredible new power comes incredible new risk. When you connect an AI to everything, you also create a massive new surface area for attacks. The same protocol that lets an AI build an app could, in the wrong hands, be used to steal your data. Okay, this threat model looks a little complex, but it shows a really crucial point. Vulnerabilities can pop up at every single layer of the system, from the AI model itself to the host, the client, the server, and the tools it connects to. Every single link in that chain is a potential point of failure. Securing this whole thing is a huge, huge challenge.
And this level of connectivity creates entirely new types of threats we've never had to deal with before. Take something called tool poisoning. This is wild. It's an attack where you don't hack the code, you just write a malicious description for a tool. You trick the AI into thinking the tool does one thing when it actually does something totally different and probably harmful. It's a semantic attack. You're manipulating the AI's very understanding of its own world.
And tool poisoning is really just the tip of the iceberg. The risks include everything from classic data theft and denial of service attacks to much more sophisticated threats, like turning a compromised MCP server into a secret command and control channel for malware.
So, the challenge is crystal clear. How do we build this incredible, interconnected, agentic future, but do it securely? Well, the answer lies in completely rethinking our approach to security from the ground up for this brand new world.
The solution looks something like this: a multi-layered framework that's built on two really important ideas. First, defense in depth, which just means having security at every single level. And second, zero trust, which is a modern security model that's perfectly suited for this kind of dynamic environment.
So what is zero trust, really? Well, in a world of these temporary, dynamic AI connections, you just can't rely on old security models. Zero trust is built for this. First rule, never trust, always verify. Every single request is treated like it might be hostile and has to be authenticated. Second, just-in-time access. A tool only gets the permissions it needs for the exact moment it needs them, and then they're gone. And third, continuous validation. Trust isn't something you grant once, it's rechecked for every single interaction.
Which kind of brings us right back to where we started. The Model Context Protocol. It's more than just a piece of tech. It's a doorway. By solving this massive connection problem, and by working to solve the security challenges that come with it, we're standing on the edge of a whole new era. The question isn't if our AIs will interact with the world anymore. The real question is, what incredible things are we going to build when they finally can?